Fractals. A fractal is an object that have parts that look like the whole object. For example, take a small section of the night sky. It looks very much like the whole night sky. Without a sense of scale, some building in the picture or the moon, we have no idea whether the photo is of a big stretch of sky or a tiny zoomed-in section because they look the same. Look at this picture. It's a picture of the night sky. Is this a big part of the sky looked at with the naked eye? Is this a picture zoomed in with the telescope? There's no way we can tell because a little bit of the sky, if you zoom in enough, looks just like a big part of the sky. It is full of stars. Furthermore, another example, take a small twig of a pine tree. It can look like a very tiny pine tree all by itself. You can have a big, beautiful Christmas tree in your house, and if you want to have a Christmas tree for your dollhouse, you can break off just the tip of somewhere off the tree and have a little tree that looks like a big tree. Now, these objects, now we've said before that a set cannot properly contain itself. Thus, things like the set of all sets are impossible objects. You can't have, if the set of all sets should contain itself, it's crazy. Now, this is because sets contain discrete individual objects which are sort of chunky. It's an element or it's not an element. You can't chop elements up into bits of elements. They're not infinitely divisible. To be truly fractal, the detail has to continue down to be infinitely small. So actually, yes. If I showed you, a piece of a pine tree, you could tell me whether it was a big piece or not by looking at the size of the pine needles. So trees are sort of fractaline, or fractal-ish, or fractally, whatever you might want to call it. It's sort of like fractals, but not necessarily. Another popular example is sort of a cloud. You look at a cloud, little bits of cloud look like clouds. Or rivers, little bits of rivers look like rivers. It's very hard to tell because they're fractal.